Module 4, Exploratory Data Analysis, EDA. Exploratory Data Analysis, EDA, is the process of analyzing a dataset to summarize its main characteristics, often with visual methods. EDA helps you understand the structure, patterns, relationships, and anomalies in the data before applying any formal modeling techniques. Purpose of EDA: to understand the underlying structure of the data, to identify patterns, trends, and correlations between variables, to detect outliers, anomalies, or errors in the data, to prepare the dataset for modeling by performing necessary data transformations. Key techniques in EDA. 1. Univariate analysis. Univariate analysis focuses on single variable statistics. It helps to understand the distribution of data and is the first step in identifying patterns and trends in individual features. Common techniques. Descriptive statistics. This includes measures like mean, median, mode, variance, and standard deviation to summarize the central tendency, spread, and shape of the data distribution. Visualizations. Histograms display the distribution of a single variable. Box plots visualize the distribution and identify outliers. Density plots show the smooth distribution of a variable. Example: if you're analyzing the age distribution of customers, a histogram can help you visualize how customer ages are spread across different age groups. 2. Bivariate analysis. Bivariate analysis examines the relationship between two variables and is used to identify correlations and patterns that could be useful for modeling. Common techniques. Scatter plots visualize the relationship between two continuous variables. Correlation matrix computes and visualizes the pairwise correlations between numeric variables. Crosstabs, contingency tables used for categorical data to assess the relationship between two categorical variables. Example: you might use a scatter plot to explore how years of experience correlate with salary for employees. 3. Multivariate analysis. Multivariate analysis involves the examination of 3 or more variables simultaneously and is useful for detecting more complex relationships in the data. Common techniques. Pair plot, a matrix of scatter plots to visualize the relationship between multiple continuous variables. Heat maps display the correlation matrix between multiple variables, highlighting strong and weak correlations. Principal component analysis, PCA, a dimensionality reduction technique that transforms correlated variables into uncorrelated components. Example: you could use a pair plot to analyze how age, education level, and income correlate with each other. 4. Handling categorical data. Categorical variables can be analyzed to observe distributions, frequencies, and relationships with other features. Common techniques. Bar charts show the frequency of categories in a categorical variable. Stacked bar charts compare categories across different groups, e.g., the number of male and female customers across various product categories. Pie charts display proportions of categories, though bar charts are typically preferred for categorical data. Example: you could use a bar chart to examine the number of sales by region or the distribution of customers by product type. 5. Outlier detection. Outliers can distort statistical analysis and models, so it's crucial to identify and deal with them during EDA. Common techniques. Box plots display the spread of data and highlight any potential outliers. Z-scores, values that are far from zero, usually beyond +3, are often considered outliers. Example: if you are analyzing a dataset of house prices, extreme values, e.g., houses worth several $1,000,000 in a low-price neighborhood, can be detected as outliers. 6. Feature engineering in EDA. Feature engineering involves creating new features from existing ones based on insights gained during the EDA process. For example, If you are analyzing customer purchase behavior, you might create a new feature for days since last purchase to help model customer churn. Real-world example: exploratory data analysis of e-commerce data. An e-commerce company wants to analyze customer behavior data. The dataset includes variables such as age, location, number of visits, total purchases, and product categories. Steps in EDA. 1. Univariate analysis. The company first uses histograms to understand the age distribution of customers and box plots to visualize the distribution of purchase amounts. 2. Bivariate analysis. A scatter plot is created to examine the relationship between number of visits and total purchases. The company calculates the correlation coefficient to determine if more visits are associated with more purchases. 3. Multivariate analysis. The company uses a pair plot to see how age, location, and total purchases correlate. They also perform PCA to reduce the dimensions of the dataset while retaining important features. For handling outliers, they detect some extreme purchase amounts that could be errors and remove those outliers from the dataset. 5. Categorical data analysis. The company uses a bar chart to visualize the frequency of different product categories purchased. Glad you could make it to the end of the module. Take the quiz to continue to the next module.